Okay, we're integrating stuff now. That's just slightly harder than what you had at Core 2. So at Core 2 you could have done this by using your binomial expansion to expand this bracket to the power 5, but it would have been very tedious. Okay. Now we might think this reminds us very much of x to the power 5. So we could have a guess at this. We could guess that the answer is some function like y equals a bracket to some power. Well, what power do we think it should be? Well, we know when we integrate just x to the power 5, we get a power of 6. So we might think the answer is something like x plus 1 to the power of 6. Okay, well, it's probably got a fraction in front of it. But if I'm having a guess that needs checking anyway, I might as well guess the simplest guess and adjust any constant later. So if we differentiate our guess, what would dy by dx be for this? Well, this is u to the power of x. Okay, this is a chain. Okay, so I'm going to use the quick method for the chain rule. My u would have been x plus 1. My inside function of is x plus 1, so that differentiates to 1, so that would have been the du by dx. And y would be bracket to the power 6, or u to the power 6, which differentiates to 6 bracket x plus 1 to the power of 5. So when I differentiate this guess, I get 6 times bracket to the power 5. But what did I want? I wanted the answer to this, if I'd guessed exactly right, to have been the thing in the integral. Remember, what we're doing is integration is differentiation backwards. So I'm trying to guess the thing that, after being differentiated, gives me the function inside the integral. So my corrected guess, okay, I need to think about how to change my guess x plus 1 to the power 6, so it's going to be basically that, in order to get exactly the right answer. And the answer I want doesn't have this 6 on, so I need to put 1/6 in front of it, and I need to put the plus c, of course, because it's an indefinite integral, and that's my answer. Okay, so we're beginning to think, look, a bracket to the power of 6 has integrated to a 6th bracket to the power of 6 plus c. Okay, there's a bit more to it than that. Okay, this looks very much like brackets behave like x's when we integrate them. Let's do one more that way. Okay, so let's guess again. Y equals bracket to a power, and the thing I'm integrating is bracket to the power 4. So the thing that would differentiate to that is probably going to be bracket to the power 5. Now you may well want me to put a 5th in front of that, but I'm not going to. In fact, it would be wrong this time. Keep your guess simple if you're going to use this method. I call this guess and differentiate. So I've guessed something that I hope will differentiate to something close enough to what's inside the integral. It doesn't have to be exactly right first time, because I always come back and correct my guess. So my dy by dx for this, the reason why the 5th wouldn't have been right is that when we differentiate this, we do have to use the chain rule properly. The inside function, the inside function 3x minus 1 differentiates to 3. And the outside function, which is bracket to the power 5, differentiates to 5 times bracket to the power 6. No, it doesn't. It differentiates to 5 times bracket to the power 4, of course. And this is pretty much what I wanted. I wanted to get bracket to the power of 4, but I've got 3 times 5. I've got 15 in front of it that I didn't want. So my corrected guess, my corrected y, so this wasn't my guess, this was what I got when I differentiated the guess. This was the thing that very nearly succeeded in differentiating what it ought to. But in order to differentiate to exactly what it ought to, it needs a 1/15th in front of the 3x minus 1 to the power of 5, because otherwise this 15 that I don't want, that isn't here, is going to appear. And I need to put a plus c on the end, and that's the answer to my integral. Okay, so we've got 2 more to do like this. At some point, it's really helpful on these to know how to adjust what you would normally do in terms of power of x's. We will come back to this method that I call guess and differentiate. But we can actually see a pattern in these. When I've got a linear bracket, so there are no x squareds, there are no cos's or e's or whatever, this is just a plain ax plus b inside the bracket. So its derivative is just the number in front of x. So here that was 1 and here that was 3. Then what happens when I differentiate a bracket to a power when it's a linear bracket is that what normally happens, this was just as normal. Bracket to the power of 6, you get 1/6 bracket to the power, bracket to the power of 5 we're integrating, bracket to the power of 5 integrates to a 6th bracket to the power 6, just as if it was an x to the power 5. This one wasn't quite the same. x to the power of 4 would have differentiated to 1/5 x to the 5. But we had an extra thing going on. Because we had a 3 in front of the x, we have in fact to divide by that 3 as well, because we saw when we differentiated with the chain rule, an extra 3 would pop out. So that gives us this rule here. If there's something I know how to integrate, a little f, whatever that is, integrates to a big F, then if I'm integrating that changed by just having a linear bracket instead of x, then I could do what I would normally do, but I just need to multiply by an extra factor of 1/a. That will make more sense if we do it with an example. So here, okay, the first thing I've got to do, I'm integrating a fraction, but 1 / bracket squared, of course, just is 1 / bracket. I can use a power of -2 dx. So just as in core 2, negative and fractional powers may be needed because we've got squaring or square rooting or 1/ing going on. Here it's 1/ing, so I need a negative power. Okay, so what would normally happen if I'm integrating an x to the power of -2? Well, be careful, the power goes up by 1, but from -2 that means it would go up by -1. So x to the power -2 would integrate to x to the power -1 with a 1/-1 going on as well. You divide by the new power. So that's a minus sign. I'm dividing by the new power of -1. But what's inside the bracket is not a plain x. It's something with a 4 in front of the x. So if I did the guess and differentiate, I made this guess and differentiated it, apart from anything else, I'd have a 4 from differentiating the inside function that I don't want. I don't want anything in front of this bracket. So as well as the minus, I need to put in this extra 1/4. So in terms of what we were talking about here, I know how to integrate the function of the bracket. So if I do what I would normally do, I need to have an extra 1/a in front of that. So here, for x to the power of -2, I'd get minus x to the power -1, but because I've got a 4 in front of the x, I get -1/4 times bracket to the power -1 plus c, and that's the answer to my integral. Okay, so part D, okay, first thing I need to do is write it as integral of a bracket to a power. So inside the bracket I've got 1 plus 3x, but the power I need to get as square root, of course, is a power of 1/2. I should say dx after it, that's fine. Okay, so what would I expect? For x to the power of 1/2, I'd have x to the power of 3/2. So the new power is 3/2, so I'd need to divide by that, so I'd need to lob a 2/3 in front of it. That's what I'd do with x to the power of 1/2 in core 2. But I've got something else going on. I've got a 3 in front of the x. So I've got an extra factor of 1 / that 3 coming out in front. And of course the bracket has still got 1 plus 3x in it. So my answer is 1/3 times 2/3 is 2/9 of bracket to the power 3x to the power 3/2 plus 3x, bracket 1 plus 3x to the power 3/2 with a plus c on the end. So that's the answer to this one. So we could have done all of these using the guess and differentiate method. And if you are confused by these last two where we used the rule, then you can go back and do them by the guess and differentiate method, and you should check that these answers work. Guess and differentiate we will come back to when we do integration by inspection, but from now on we're going to get used to the fact that when we've got a linear bracket we can integrate as normal, but we get an extra 1 / whatever the thing is in front of the x. So when I had 3x I had 1/3, when I had 4x I had 1/4. Okay, so on this one here there was a 3x, that was also 1/3. This 15th came from that 1/3 together with the 1/5 that I'm expecting because I've integrated up to get a power of 5. I hope that all makes sense.